So our next algebra topic of review in this second video is how to multiply two binomials. So we need to know what that word means. And bi means two. So we have two terms. For example, this would be a term and this would be a term. We'd have two terms. This expression right here in the box has 5 terms, separated by addition and or subtraction. So for example, if I just chose these two terms, this expression would be called a binomial. So here's just some examples. 1 term, 2 terms. 1 term, 2 terms. So those are binomials. So we're going to be multiplying those, and you learned how to do that in exponential algebra. And we use the acronym FOIL, which stands for firsts. So let's go take two binomials and talk about what I mean by first. Let's take that 2x plus 5 from over there on the left in red here, and let's multiply it by another binomial. Let's call it x plus 3. So those are my two binomials, one in red and one in purple. So what we do is we multiply in a specific order. So what we do is we grab the first term in each binomial, first one, and we multiply those. But we have to remember that when we multiply like terms, which we talked about in our last video, we need to add exponents. So a little expression down here, if I were to do 4x times 3x, technically multiplication can be done in any order. It's called the commutative property, which means you can move stuff around. So we multiply those numbers first and get 12. And then when we do x to the first times x to the first, we add those exponents to get x to the second. Okay, a lot of people think x times x is 2x, and it's not. It's x squared. So back up to our foiling our first terms. We would do 2x times x, so number first, and as I said, x to the first times x to the first is x to the second. So we're now done with our firsts. Then we grab our outside terms. So kind of like if you were to make two fists with your hands, put them together, and point your thumbs to the outside. We would be pointing at this guy on the outside and this guy, and we multiply those next. 2x times 3 is 6x. And then the I stands for the insides, which would be the 5 and the x, and we multiply those. And then L stands for the last terms in each binomial, which in this case would be the 5 and the 3. And we don't add them, we multiply. First, outside, inside, and then multiplying the lasts. And then we'll combine these like terms. 6 of those plus 5 of those is 11 of those. So let's practice down here with our first, outside, inside, last. First, 2x times x gives us 2x squared. Outsides, 2x times 4, 2 times 4 is 8 with just an x. Inside terms, -1 times x is a -1, leave the number there, and then x. And then lasts is not going to be a 3, we don't add them, we multiply. And -1 times +4 is a -4. Our answer is going to be what's called a trinomial. So when you do these in Delta Math, it's going to say write your answer as a trinomial. Tri meaning 3, which means these like terms, I'm going to combine them. 8x's minus 1x gives me 7x's. So let's rewrite our answer as a trinomial. We'll have 2x squared from our firsts, 7x from combining our outside and our inside, and then -4 with our lasts. One more together here. Let's go 3x times 2x. 3 times 2 is 6. X times x is x squared. Firsts are done. Outside, 3x times 1 is a 3x, and there's one negative, making it a -3x. Insides, 5 times 2 is 10. Then there's an x there, but we have one negative. Remember, it takes two negatives to make a positive, which is what's going to happen here when I multiply my lasts. I really have 5 times 1 is 5, but they are both negative, so it becomes a plus 5. And then to write our answer as a trinomial, we need to combine these like terms. We're down 3, we drop 10 more. All right, so let's write our final trinomial answer. 6x squared minus 13x plus 5 is our final answer. All right, so pause the video and you try the next one. And hopefully you got, with your first, when you come back to the video, a 4x squared. Our outsides are minus 4x, but our insides is plus 1 more of those. So we end up down 3 x's when we combine the O and the I. Our lasts is not 0. It's 1 times 1, which is 1, but one's positive and one's negative, so minus 1. So hopefully that went well. And then our next task is to do some solving equations. We're going to start with our 2 steps, which means 2 things I need to do in order to solve and find the one value for x that'll make that right side add up to a negative 20. So what we do is we do our opposite operation. So to get rid of that plus 1, I subtract 1. Negative 20 down 1 is negative 21. Now I have multiplication of a 3 in front of that x. To get rid of that or undo it, I divide. I get a negative 7 is equal to x. And I'm done. So 2 steps to unravel and attack that variable. So I like to circle or highlight that variable first. So now I'm focused over here on that left side of the equation. To get rid of subtraction of 1, I add 1 to both sides. I'll be left with that b divided by 3. The subtract 1 is now gone, but over here on the right, I have a negative 4. Now, to undo division, I multiply. 3 divided by 3 is 1, so it undoes it. So you'll notice in purple, I'm multiplying both sides times 3 to get 3 over 3, which cancels. Then I get b equals 4 times 3 is 12, but there's 1 negative sign. Remember, we need 2 in multiplication or division to have it go positive. And our last 2-stepper here, well, let's go attack that y. Here it is. How do I get rid of this negative 2? Well, I'll add 2. Why would you do that? Because negative 2 plus 2 is 0, and poof, it's gone. But I have to balance it out. Whatever I do to the left, I must also do to the right. So this is gone. Notice I have a negative y over 4 left. I like to write that like this. Now, you don't have to, but it's the same thing. For example, negative 1 over 2 is exactly the same as 1 over negative 2, which is exactly the same as negative 1/2. All these are equivalent. You might say, which one do I use? It really doesn't matter. But when I'm solving, I kind of like that negative to be on the bottom because then in one step, here, let me go add over here. I've got negative 1 plus 2 is a positive 1. Now, to undo division by a negative 4, I just multiply both sides by a negative 4. Why do I do that? Cancel, cancel, and lo and behold, I've got my y left. 1 times 4 is 4, but that 1 negative sign balances out to be negative. So those are our 2-step equations, and now we're going to bump it up and try some 3 steps. So for our 3-step, we're going to have that variable on both sides. And we want to, when we're done, to get our answer to look like x equals. We want it either on the left or we want it on the right, but we can't have it on both sides. So now the first step is going to be get that variable on one side. Does it matter which side? No. So for this first one, yes, I could subtract 5x, don't write this down, from both sides to get rid of the 5x and move all those x's over to the right. But you'll notice then I'd be dealing with negatives, and we don't really like negatives as much as we like positives. So I hope you've been taught in your middle school years that you should deal with the smaller one and negative 3 is smaller than 5, because what happens then is I have a positive 8x, and I love those positives. These are now gone, which is why I did it. And now I'm back right up to the 2-step. I need to attack that x. To undo subtraction, I do the opposite operation. Why? Because these are 0, and it gets rid of it. 5 plus 11 is 16. 8 times x equals 16. To undo that, I divide. And this is how you'll be showing your work on your Delta Math supplement. And I get x is equal to 2. I could plug it in to see if it works, but I don't want to. All right, so I challenge you to pause the video and go try this next one over here. All right, now you're back. Let's see what you did. I like to add the 2x because negative 2 is smaller than that negative 1. Remember, when there's nothing there, it's really a 1. So I'm going to be moving all my x's onto the right-hand side. These are gone. Negative 2x plus 2x is 0. I have just a 6 left. A negative 1x plus 2x's gives me a positive 1x. Now, again, we don't really need this there, right? When it's a 1, not necessary, but it's there. So really now all I need to do to attack that x is, and it's on the right-hand side, so I have to get rid of all those numbers on the right-hand side, which is just a plus 3. So I subtract 3, bam, I get 3 is equal to x. Okay? Now, our last kind here for this video. What do I do when I see those parentheses? Well, when x is stuck in the parentheses, before you can do anything else, you got to get them out of there. To get them out of there, you distribute, which means you multiply that negative 3 in. Remember, 2 negatives make a positive. So 3 times 2 is 6, but those 2 negatives make a positive. Okay? Now, I've got 3 times 5 is 15, but there's only 1 negative. So when I distribute in, I get 6x minus 15, and those are equivalent expressions. So when we're solving with parentheses, what we need to do is get that variable out of there. So we're going to distribute the 2 in on this one. We'll distribute the 3 in on this one. On this one, we'll distribute the positive 3 in. And on this last one, we'll be distributing the negative 4 in. All right, let's go do it. 2 times y is 2y. 2 times 3 is 6, but there's only 1 negative, so it balances out to be negative. Now on the y attack, I've got subtract 6. Opposite of subtracting is adding. So I'll have 2y is equal to a positive 10 on the right. 2y means 2 times y. To undo multiplication by 2, we divide by 2y, because 2 divided by 2 is 1. So now I have 1y is equal to 5. I think I'll check that one. Order of operations. I would do 5 minus 3 is 2. 2 times 2 is 4. Bam, it balances. Bam. All right, let's go do our next one. Negative 6 just hangs out until we're done getting that p out of the parentheses. 3 times p is 3 times p. 3 times 8 is 24, but there's 1 negative. Remember, I need 2 negatives to make that a positive. Now I'm on the p attack. P is over here on the right. To undo subtraction, I add to both sides. Negative 6, and then I go up 24 degrees. I'll be at 18 above 0. It's equal to 3 times p. To undo multiplication by 3, we divide by 3, and we get 6 is equal to p. Let's go check it. 6 minus 8 is negative 2. 3 times negative 2 is negative 6. Score. We are so good. All right, I would challenge you to pause the video and go try number 3. Now that you're back, let's see if you did 3 times 12. 4 gives you 12. They're both positive. 3 times 5 gives you 15, but there's 1 negative. Minus 4x hangs along, plus 1 hangs along. Negative 6, just there. Now we have some like terms over here on our left-hand side. Don't forget to take the signs with you. 12x's minus 4x's gives us 8 of those x's. Negative 15 plus 1 gives us negative 14. Don't forget those signs. And then I have a negative 6 over here on the right. Now to attack that x, what do? I add 14 to both sides, and again, let's think of temperature. It's down 6 degrees and rises 14. We're going to balance out to be positive 8. And now to undo multiplication, our last step is always to divide here, and I get x is equal to 1. All right, and our last one of these. Sorry, I was hoping to keep it to a 15-minute video. I don't like to go over 15 minutes, but it looks like I'm going to be more like 17. Uh-oh. All right, let's do 4 times x is 4x. 2 negatives makes a positive. 4 times 1 is 4, but those 2 negatives make a positive. 2x is hanging around. 3 is hanging around. 43 hanging around. Step 1 is done. The parentheses are gone, but I've got some guys here who go together. 4 x's and 2 x's give me 6 of them. You might say, you said I add the exponents. That's when you multiply. So again, 4x times 2x gives me 8x to the second. But when I'm adding them, I have 6 of them, right? All right, so I have 4 plus 3 is 7, or 43. And next up, it looks like I need to subtract 7. Subtract 7, I get 6x is equal to, what's that, 36? And our last step always is to divide by what's in the way there, what we're multiplying by, and I get x is equal to 6. So that's the end of this video. We only have one more little task, and then that's the end of our algebra review. Have a good one.